Yes, yes, your screen is visible.
Yes, visible.
Okay, let's start. So in this session, I introduce how to implement the coding section of the signal using MATLAB. So I hope all are familiar with MATLAB. This is the MATLAB. I use 2023A, the version of the MATLAB. So after downloading the file code DWD plus CNN, there are 3 folders. Okay. So first folder is for CNN, convolutional neural network. Here we use CNN for implementing and classify the heart disease. Then this is the data folder. Here we have 5 classes of data like A stand for aortic stenosis, then mitral regulation, then MS, then mitral valve prolapse, then normal. So these are the different types of heart sound which are going to be classified in the upcoming or subsequent. So first we have implementing by using machine learning. So we all are familiar with machine learning. So what is machine learning? Machine learning is nothing. It automates the training. It automates the process by which we can classify easily all type of heart disease. So before going to all of this, first we have to know what is aortic stenosis. It is a condition where the aortic valve, when the aortic valve is narrow, then aortic stenosis is occurred. Then mitral regulation. This is,
Pratyusa,
yes, sir.
you may skip. I have discussed the introduction about it, so no need to go in detail about these things. You can skip, right?
Okay. So we only focus on the how to implement this in MATLAB only. So first we have 3 folders: CNN, then data, then ML. So in first we have to open our MATLAB, then click this icon. By this, browse the folder. We have to browse the whole folder into the MATLAB. By click this, we select the folder. Then all the subfolder like here is appeared here, your current folder section. So now we do one by one. So first thing is ML, then data, then CNN. So before going to, we have to add the path. Like in Python, we know how to add the path, go to environment variable, then add the path. But here the add path is somehow different. Then for adding path, you have to go first home tab, then set path. Then here we add the folder. Click by add folder. You have to add CNN folder, ML folder. I have already added here. This is my CNN folder. This is my ML folder. And also we have to add this folder. After few times I told what is this folder. Now you only looks. We have to upload 3 folders: CNN, then ML, then this. Here I added already these 3 folders. So now we are look how this work. So here various type of data is there. So first we have to know what are these. Then there first is MATLAB code. MATLAB code is the type is MATLAB code. It is the MATLAB file where we can manipulate, then processing, then different application each occurred. Then this is the MS table type file where the features are stored. As you know, the features are stored in CSV format, also in Excel format. Here the MATLAB stored the feature in the Microsoft Access table shortcut type. So first we have to open chapter. Here all the code are mentioned here. So first we have to know this is the simple type of code for clear, close all, CLC. Clear means clear all the command that we have integrate or we have to trigger. Then close all. If some application is closed, then it by applying this, the all application closed. Then CLC is clear screen. As we know in CMD also there is a function CLC clear like that. So first we have to go data preparation. We know we have data. If we apply machine learning, if we apply machine learning algorithm direct to the data, there is some noise or some null value, and there is some type of disturbance in the data because these are the raw data. So we have to first preprocess the data. Without preprocessing, we can't do anything. So first we have to preprocess. So this step is going to first load the path directory, then column index. Here we assume 1 for AS, 2 for MR, 3 for MS, like on. Then data preparation. It is another MATLAB code which I will show. Then save all the features, then clear screen and CLC. So first we have to know, first we have load the AS folder from data directory. This is AS load. Then column we set AS as 1. Then what is in data preparation? By Control D, we go to direct to the data preparation.m folder. Control D. First select this, then Control D. Then now we are focusing about data preparation process. So first data preparation, we have data. So we have to first load the data, where in path directory it automatically fetch in the data preparation. So in first we have load all the WAV file. WAV file means the sound file. We know the sound are recorded in .wav, .mp3 and different version of the sound. Here we focus about the .wav web file. So first original files we loaded, then we select the number of features 156 because the signal are different in length. Some signal are too long and some signal are too less. So if we have not selecting a particular number, then there is a dimension mismatch. If dimension mismatch occurs, then machine learning model also not work because machine learning model is work in a matrix type of data. So we know in matrix all the row and column are must be same. Otherwise, it's not doing any operation like arithmetic, then multiplication. So we have to ensure that the matrix size should be same. So here we fix the number of size to 156. Then we create a feature vector. As you know, here we only extract the feature. So we have to first create a feature vector. We initialize with zeros, yani all the value first in 0. Like we create a empty array. This is not only an empty array of 156 value. Let me show this first. First I run this, run as a run section. Then I click this. Here my feature vector is 200 into 161. 200 is the number of data in the AS folder. In AS folder, total 200 signal there. And 161 is my total number of features. And it means I selected 156 and remaining 5 are the target level. So here if I open this, here we can see all the value are 0. It is non what a 0 matrix, which is dimension is 200 into 161. Then now we have the feature vector, also original files. Then now our work is start. So first we have to load all original files. We use for loop. We know by repeating all the files, we for loop is the best. So by for loop, file I is equal 1 to length means 1 to 200. It will run. Then display. Here I only display the which number of file is processing at the moment. Then file name. In MATLAB, by reading a file, there is a function called audio read. By audio read, it returns two things. One is the sound file, then is the frequency or sampling frequency. Then here the file name is extracted by like part directory. Part directory means your data/as, then go to the original files I data.s, then new as001. First here it trigger out 001 file. Then read this file. Then here all the file have the sampling frequency 8000. So we have to first reduce the sampling frequency to the 1000 because in by reducing the sampling frequency, the efficiency of the code is faster, and we know the heart sound range between 60 to 150 hertz. So if we 8000 hertz is not a good number, so we have to reduce the number to the 1000 so that all the important components of the heart sound is captured in between. So we have to first resample or downsample to the 1000. This function is going to do this function. Here we give the original sampling frequency 8000, then the desired sampling frequency 1000. Then this function is downsample the original signal, then it return in the x. Then here we check if the length is less than equal to sampling frequency or desired sampling frequency into 2, then length of the signal is less than 2 seconds. Here we only plot if those are the is not criteria, not satisfy the criteria. Then we have to denoise. So let me first. So what is noise? Then we have to know how we need denoise. So let here I am read AS001 folder, or there is a sound called new AS001. So I have read this first. I am reading, then then now I am downsampling this. Then I add white. There is two here. I mentioned two type of noise. One is pink noise, and another is white Gaussian noise. So first we so how the pink noise is looks like in a sound data. If I run this, let I plot. Here we see this is my clean signal and this is my noisy signal. Here we see how the noise impacted the signal. Here the clean signal, in the clean signal after noisy added, the clean signal is distorted, and here we cannot be see any type of information. So first we have to denoise it. Then after we can going to add we extract the some feature. So for this we have applied denoising technique. So there is different type of denoise technique like wavelet transform denoise technique, then time frequency denoise technique, then we have TQWT denoise technique, and also now the trends in deep learning and machine learning based denoising like autoencoder, encoding, decoding, like that. So here we use simple traditional denoise technique, wavelet transform. In wavelet transform, we first select the which wavelet we have to want. Here we use coef 5 coef wavelet, then 5 is the 5 coef 5, then in which level 5, then percentile, methods, level of TQWT, R and Q. Then we use this function, then this function length should be odd for TQWT, then ensure the data is a column vector. If data is not in column vector, then the machine learning algorithm or the is not working. Then normalize. We should also normalize the signal. Otherwise, it not be efficient because some signal have amplitude very high, some have amplitude very low. If we directly put in to the model, then the model might be unbiased. So we have to first normalize this. Then here we use the TQWT denoising technique. This is the simple TQWT denoise technique. By applying this TQWT decomposition denoise technique, then we here the denoise signal is obtained. Then we use Springer B matrix, then Springer pi vector. These are the these things are obtained from this folder. This folder which we will add in the set path. These are this folder. Or this folder is created by PhysioNet's team, in which we just load this file and we do our work. So here we use three type of Springer total absolute distribution, Springer pi vector, then Springer B matrix. Then we extract the state like there is S1 systole, S2 diastole. So here we extract the different state of the data. Then after extracting, then we fill the feature vector now. The first in the first feature we have to fill the mean of value RR interval. If I run this code, if I first run this, here the file number, each file now each file is processed and each file have calculating the mean value of the RR interval. Now is 65. It is shown because of I use this display function file number of string. So by this we know which file now processing. It takes time. Okay. Now if I see the feature, here we see the only first column is filled because I only extract the first feature, which is the mean value of the RR interval. Then if I use the second feature is my mean value of the S1 interval like this, then again the all file is run, then the second column is filled.
Pratyusa, you are not audible.
Yes, sir.
Actual
file is running.
Acha.
Here we see the file is running. So now we see the second column also now filled. Likewise, all the features like then mean value of S1 interval, S2 interval, systole, then diastole, then different type of statistical parameter like kurtosis of S1, the systole, S2 diastole, then a phenofactor, then ZCR value. Like that, here we mention the 156 features. Likewise, all the features are extracted from this. Likewise, all the features are extracted, then the feature value looks like all the value are filled. Then we go to the After all the feature value are filled, then we save the all feature value. Then clear screen and then clear screen. Then again do for the MR, again do for the MS, like that do for the all. Let here I am not running all the code because I already run and save all the features. Directly we see the features. Let I load the all the features. Here I load all the features. First AS. Here for AS, these are the features 200 feature. Then 156 column. 161 column. Here we see some it range it only given from 179. Then like MR is going to 156. Like so after that all are zero. So no need for taking the zero value. So we have trimmed this matrix to AS to 179, then MR to 156, like then MS to 171, like that, because zero are no need for this feature, because zero is not a feature. We only look towards the features. And the now here also we take this. In AS we take from 1 to 173, like MS 156, like means how in which in how much row the value is present, we take only those row, and those row are zero, we only discarded this. Here we set our features, then we save in X, this feature in X, and Y contain our levels. Here we see, let I'm opening again AS. In the last, after 156, 157 to 161, it is my the target. Means here I use one hot encoding. I hope all are familiar with one hot encoding. It is a nothing but a vector encoding process or binary encoding process where we can use the number of row as column and put 1 and 0. Like if I let we have AS, MS, MVP. Then we create a column. And we set here AS, then here MVP, then here MS. Then we put this 1 0 0. Then again it's 0, this 1, this 0. Again this 0 0 1. This is the one hot encoding vector. In one hot encoding vector, the number of the column vector is the total number of the target. If we have n target, then n number of column is there, and the matrix represented by this 1 0 0 0 1 0 0 0 1, like that. So here also we use the first one hot encoding. Then we use level encoding. Level encoding means we assign a value to the specific target. Let for S we give the 1, MR we give the 2, MS we give the 3, MVP we give 4, and N we give 5. So you have two type of encoding. And why you use encoding? Because here we know the AS, MR, MS, MVP, N are the string type of data. So if we give directly to the machine learning to the string, this not be what, because machine learning is a mathematical model type of model. So there is we use Y is equal to MX plus C, or in logistic regression, then SVM, there is some mathematical calculation occur. If we give direct to the string to this model, then it will not work. So we have to convert it to integer, then we fed into the model. Okay, then now we have X, which is my all features. Then this is my y is my one hot encoding. Then this is my z is level encoding. In between y z you choose anyone. Here I choose z, which is very simple because in y it unnecessarily create additional column value. For like I say, if n target, the column is n, so it is tends to the dimensionality, dimensional cost of dimensionality. So by this also dimensional increases. So reduce it, we use level encoding. In level encoding, in one column all the value are present. Like here we first one for s, then 2, 3, 4, then 5. So now I load the data, then process it, then extract the relevant feature, then we save it into the x and y and z variable is my target, where y is the one hot encoding vector form and z is the level encoding form. So now we are going to our machine learning model. So now because we have features and target and their respective target, like this is my feature, this is my target, like this row 1, all the features corresponding to Z row 1 means 1 AS. Like that, second row corresponds to this, third feature corresponds to this. So ensure that the dimension must be same. Like in X, the dimension is 830 into 156. 830 is number of signals and 156 is my total number of features that I have here mentioned. We take the total number of features 156. And Z 830. 830 means 830 signal and one column. So must be ensure that the number of rows should be same, 830 and 830. Otherwise it will reflect some error, dimensionality mismatch or different kind of error. So till now, any doubt? Hello, am I audible?
Yes, you're audible.
Yes, sir, yes.
I guess till now no one having any doubt.
Okay. So now we use machine learning model, different machine learning model for predicting the class. So here we use SVM. Let me see what is in SVM, like control D. Then here we split the data X and Z. Because we know when we do in machine learning algorithm, there is a train test and test set. In train set, we train the model, and test set we test the model for the evaluate or performance, how the model give the performance. Then this is my train X train Y train, then X test Y test, then Z test. As I mentioned in Z, we also give. Then we have 5 class 1, 2, 3, 4, 5. Then we use a SVM. We use a SVM model. We use a SVM model. Then SVM model, here we fit SVM. Then as you know, SVM has different type of parameter like class name, standardized, then kernel function. There are different kernel function, polynomial, RBF, linear.
Wow.
Then hello. Then order. Then after this is my SVM model. After SVM model initialize, we train and predict the SVM model. And the after prediction, if I run this, this is my confusion matrix. All are familiar with this confusion matrix. And here here is my accuracy. The SVM is give 96.99 accuracy. But the thing is, here we see, there is a lot of code here. But if someone not familiar with this code, and if not someone not know the how we create a model or how we initialize a model for MATLAB, so what we can do? So MATLAB provide a beautiful feature in ARC section. In ARC section, there is a called classification learner. This is an app where we can build our own machine learning model and or we directly run it and getting the accuracy. Like I click this classification learner. Takes some time. Here we only use drag and drop technique by for doing any type of machine learning work. So it is very useful and very time efficient. Learner. Now it open. In this section, there are several type of tab like first is the file, then option, then models, train, plot, and test. So first we go to the new section. Click plus. Then it and the beauty of this feature is it automatically select the target. Like here I first select the features. Like X is my features, and here I select the automatically select Z. Here I not select the manually for Z. For X, it knows the Z is the target, and here also it automatically train and test or automatically split the X and Z. So we don't worry about the train test split and standardization anything. It automatically do. So here we first we give the X variable as a feature and Z variable as target. Then here we use also cross validation. Here different cross validation technique, hold out, cross validation, redistribution validation. Let I use cross validation fivefold. Then here we use also test data. Let I am not click this. Let's start session. Now the file is loaded successfully. So there are different, now all the tab is open. So first is feature selection. We know there is a different type of feature selection method like PCA, then LDA like that. So if you here use then the different feature selection technique is open. Then it is PCA, then it optimize the cost or return the how much cost, then is optimizer, then we concern about this model. Here, all the model, most of the model are mentioned, like for decision tree, fine tree, medium tree, coast tree, all tree. Then for the discriminant analysis like that, LDA, quadratic discriminant. Then like for logistic regression also, then I bias, support vector machine, efficient trend, KNN, like that. All the model are also neural model also here included, like narrow, shallow, wide. Then optimized neural network, all neural network type here mentioned.
Hello.
So, yes.
Yes, I have a minor doubt actually. Sorry for the interruption. If the data is in Excel format, not in CSV or something like that, exclusively Excel, is it possible to read the data directly here?
Can you again repeat?
If the data, for an example, for I'm interested in doing suppose PCA, right? So if the
Okay.
data are not in CSV, it's directly in Excel format. Okay, so is
Okay.
it possible to read the data and doing PCA using this classification learner?
So you first read the data in MATLAB, then you open the workspace and you read. It will work.
Okay. Okay.
In CSV, Excel, it has all are same, na? Excel, CSV, then the Microsoft to Excel, sorry, Microsoft tab file, all are the same. So you can do.
Okay,
so
got it.
answer is yes.
Hello, sir.
The answer for your question is yes. MATLAB supports most of the formats of the files, including the CSV, Excel, and all. But first of all, you have to load whatever the format is in the MATLAB .mat file, right? So you can load the data, whatever in the format it is available, Excel or .csv or .txt or whatever. You can bring it into the MATLAB workspace. It will be in the .mat format, and then you can use whatever Pratyusa is explaining.
Hello.
Thank
Sir,
you.
my voice is audible? Hello?
Yes, yes.
Yes, sir, I have a doubt. In the classifier learner app, when we can select the cross validation, that is hold on, and when we can make it hold on. What scenario we can consider is a cross fold validation, when we can make it hold on validation in the app, classifier app for any data set.
I will mention means we use this 5-fold cross. Acha, hold on and all, right? So regarding that,
Yes,
actually,
sir, when that scenario, when we can consider, when another one we can consider any specific.
I will have to exactly check what is the specific setting in this particular thing. So okay, I can share that one. Hello.
There are also hold on validation also there.
Yeah. So what I'm saying is that I'm not pretty much sure about the hold on characteristics of this particular. There is noise from another one. Okay. Okay, so I'm not pretty much sure about the specific feature of this hold on, what exactly this particular classification learner of hold on does. But regarding that multifold, I have already explained in my presentation that when we do the multifold classification. So means I do not have an exact comment regarding the hold on. If Pratyusa may add, that's okay. Otherwise, we can share that information at a later stage.
Hello.
Yes.
Yes, sir. One more clarification. In the classifier learner app, can I get the losses curve and the accuracy curve training during? Look like that graph with the epochs is possible.
Okay.
Yes,
most of these, in case of classification learner, most of these models are okay. Most of these are classical models. So yes, we can do that. But generally, in classical machine learning models, we do not use the validation of curves.
Okay, but we don't get the losses curve. I need graph. If possible, in the classifier learner app.
You can use the ROC curves here because means during these classical machine learning models, ROC curve is there, the loss curves or accuracy curves. Because
Okay,
there are
ROC curve.
here we are using the epochs.
Okay. Yes.
In case of it, there is another application of the neural network and deep neural network, where you also get those curves. But in case of classical machine learning models like SVM and Bayes and so on, we do not use the epochs. That's why there is no loss or accuracy during the training.
Okay.
Yeah.
Okay,
So
sir.
there is a separate application for neural network and deep learning, but Pratyusa probably will explain when he will discuss the CNN.
Okay, sir. One more, sorry, before end. That best feature, they are given many technique. One is for in the app. This is size pair, ANOVA for feature selection.
Yes. So actually there are various
about
techniques.
this?
Yeah, there are various techniques. Once you have selected, let's say in our case, we have selected around 156 features, right? So
Yes.
you assume that, okay, no, you do not want to go with the 156 features. Suppose your data size is 10,000 and with the 156 features for each sample, that would be a very large data set for a, let's say if you want to implement on a smartphone. So what you can do is that you can reduce the number of features. How you'll do that? You can use either the concept called PCA, right? That is available here. The otherwise you can do the different kind of studies, including the ANOVA, regarding the covariance matrices and all. And then you can
Okay.
select the features. You can minimize the set of features, or you can transform the domain of the features also, and then you can use the models to classify.
Okay, okay. But one thing, if the selection of the features using ANOVA size square, accuracy also different, or we get the same accuracy only?
Yeah, of course, accuracy will vary. Accuracy will vary corresponding to the how many features you are using. Let's say, means in the PCA, how many percentage of the energy you want to contain. Let's say 95%, 99%. Accordingly, the number of features will be reduced, and accordingly, the accuracy will also be impacted.
Okay.
Yeah.
Okay, sir. Thank you. Thank you.
Okay. Okay, Pratyusa, continue, please.
Okay. Okay. Now there are different type of tabs like feature selection, then models, then then result table, summary, like this. Here first we have to train a simple. Let I click a simple decision tree, find tree model. Let I delete this. It is simple. Here we use some maximum number of split, then split criteria. There are different type of split criteria. Here we use Gini criteria, then decision split. Then here the some other features like feature selection, individual feature selected. Then PCA here we not use PCA. Then optimizer not use. Then misclassification cost default. Then if I run this, train. Wait a minute. First, I load all the features. Classification learner. First, I load all the features. Then I go to the classification learner, select from workspace. Then I select X. It automatically select the Z. Then start session. Let's first train the first decision tree. This is my scatter plot. If I train first, crash. Okay, my actually classification learner is crashed, so I only demonstrate how you train a model. First, you select your x and y variable, x and y. Here I'm not training the model because the MATLAB crashed. So after selecting then you can use anyone, train all. If we use train all model, all the drafted model, here we select different type of drafted model. Here all the model are in draft form. If we want to run all the model, then we go to the train all. By this, all the model are simultaneously trained. If we train one by one, then train selected. Here also we add all at a time. Here multiple model are also included. If we click, and here is the option all quick to train. If I click all quick to train, all the model are here display here, and the model are train started. So here I am not clicking the train, otherwise the MATLAB is crashed. After training, then we can plot different type of matrices like confusion matrix, ROC core, parallel coordinate, then confusion then by this different type of plot also we can plot. In this way, we can easily build a machine learning model and directly work with this without knowing how we write a machine learning model or what are the different parameters of the machine learning model. And we can export our model for the future purpose, or we can implement this in the Android application, web development, and so on. So like this, the classification learner is very useful for beginner or who are not know about much about how to code a machine learning model in MATLAB. Okay, now all the machine learning perspective of the classification is done. Now we are go towards the CNN, convolution neural network based model. Am I audible? Hello.
Yes, you are.
Yes,
You are audible.
Okay. So now we all know how we implement a machine learning, how we extracted different features from a data, how we read the data, how we access the data, and manipulate different things. Now we do same thing in deep learning. Here we use CNN, convolutional neural network. Likewise, in machine learning, we use one-dimensional data, but in convolutional network, we have to use two-dimensional data. So we first, like in machine learning, we first read the original files, then column index we give, then data read. In data read, we first read the data, then resample in 1000, then we use some technique for store the data. After that, here I directly load the data. Here I first load the data. Here the data is 1000. 1000 means there are total 1000 of signal. Means in each we have 5 classes, and in each classes have 200 signal. So total 1000 signal, and 5000 is the number of features. Like I said earlier, some signal have very long and some signal very short. So if we not set or trim the signal so that we cannot do anything. So here we trim the signal by 5000. First, here we extract the feature. Here we use DWT, discrete wavelet transform. Before in machine learning case, we use 156 number of different features like mean, kurtosis, variance, then other interval like that. But here we concern about DWT based feature extraction. DWT also a wavelet based feature extraction where we use different type of wavelet technique and levels so that it give the different levels. Let me show one simple wavelet based, how wavelet based is shown. First I load the first I load one signal. First I load the signal. Let I load the 1000 number of signal. Then it store into the X and define some level of wavelet level 5. Then copy which wavelet mother wavelet we used. Then sampling frequency. Also it define. Now wavelet function is the decomposition of the wavelet. By this we can decompose the different level of the wavelet. How it's see? Let's see. Here. This is my original signal. After original signal in wavelet transform, when we use wavelet transform, there are first details one. In details the low frequency is present. In detail the high frequency is present. In approx the low frequency is present. Like this. This is the details one of details one, like details 2, details 3, details 4, details 5, then approximation. Here we use also reconstruction the feature reconstructed method. Here we use wavelet coefficient reconstruction so that it gives the same length. Otherwise it automatically have, like if the signal is when original signal is 4, then detail 1 give the half, means 0 to 2, then 0 to 1.5. Like that it can decompose the original signal. But if we use reconstruction, then the signal length going to be the same. Likewise, we fed this coefficient, wavelet coefficient, to the CNN model for predicting or classify our data. Okay. I clear the screen. Okay. Okay. First, I load the data, all the data I loaded. Then we use DWT coefficient and extract the features. Here the loop is begin. Okay, it's done. Now, in my data DWT, all the features like I show here, the different levels decomposition features are here. 896 into 2942. So now this is my all features and this is my levels. Here 896 is means later I saw previously I saw that some value R becomes 0 after 173 or 153, like in machine learning. When we select here, as we select 173 AS, means AS is we take 1 to 173. After that, all value are 0. So that it not 1000. It going to the 896, and the label are all in the level including form. Then we have now our levels, then our features in data DWT. Okay. Now we again train and test split. Now we give the train set and test set. After here also first we discuss how we build a model by coding own. Then we use app section, and here is a deep learning learner. By this we can also evaluate. So here first training parameter. Which training parameter we use? Different parameter, SGDM optimizer, then epochs, then environment, then learning rate, how much learning rate, then shuffles, plots, then batch size, and last one is test. Then this is a smaller deep learning network. Let if I run this, this is smaller deep learning network, like first we give the input, then convolution 1, max pooling 1, convolution 2, max pooling 2, then fully connected and softmax. Here we use softmax because here it is a multi-class problem. Like here we use 5 class of problems. So when binary type of problem, then we use sigmoid, and classification we use softmax. Then class output. This is a smaller network for the demonstration purposes and we can build any number of convolution neural network by this. After now we train the model. Let we train the model. If I train the model, now the whole one new window is open. Here we can easily show our progress. Here we can easily show your progress. This is the epochs versus iteration. So the iteration versus accuracy. Here the iteration versus loss. So here is the epoch 1. So here we can plot the here we can see the accuracy plot, loss plot. Then here also we can see the start time, different parameters like epochs, iteration for epochs, frequency, learning rate, like this. And by this we can see the how useful the MATLAB for the plotting any type of graph. If here is so out of memory. Okay, if I go to the now we see how we do it by dragging dropping technique. Like here by for the beginner it is very difficult to build a neural network in MATLAB. So how it becomes easier? Like classification learner, there is a called deep network designer. If I click this, and main thing is if we want to run this, you have sufficient memory for this. Otherwise, it not run properly. Like here, here is so out of memory. So always ensure you restart your computer or always clear your workspace. Hello, am I audible? Hello.
Yes, you are audible.
You are audible, but your
Yes,
screen is
yes,
not
sir.
visible.
Screen is visual.
And now visible.
Yes, the screen is visible.
Now it is visible.
Okay. Deep network designer. First, when we click the deep network designer, first here we see different type of network. Like if we click blank network, we can create our own network. And there are also image network, ImageNet network like SqueezeNet, GoogleNet, ResNet. We can just install it and use it. There are different exception, ResNet 18, then VG16. We just install it and use it. Like the sequential network also, sequence to label, sequence to sequence. Here we use LSTM, by LSTM, like that. Then audio, these are the audio network, VGGs, like that. There are also a predefined network, and but here we know how we design our new network. Now this is our workspace. So here how we create our new network. So first for doing a machine learning, deep learning model, we have a input layer. So first we select a input layer. So these are my input. This is my input layer. So here different parameters are open, like name, input size. So we have first mention our input size. As here the input size is my. Let I run this again. Okay, here my input size is 896 into 2942. So this is my input size 2942. So I mention here 1,2942,1. So now this is the input of the convolution neural network model. Then you can use split complex input, then normalization. There is different technique of normalization, zero score, G score normalization, rescale 0, 1, different type of normalization. Then normalization dimension also. Now we use a convolution 2D layer. After that, a convolution 2D layer is there. For convolution also there are different filter size, number of filters, stride, dilation, padding, like that. You can use different type of size of filter, number of filters, so that you can tune your convolution neural model well. After convolution, there is a max pooling layer. So max pool. There is a max pool layer. Also max pool, also pool size, then stride, then padding. Then again I want a convolution neural network layer. Just drag and drop. If you nothing know about the coding, so you can easily go here and do your own network by own. Then convolution network, again one max pooling. Just copy paste. After that, I use a fully connected layer. Now all the convolution part is over. After convolution network, there is a fully connected layer. So I use a fully connected layer. Here I give the output size. Let my output size here is 5. As my target is 5, so output size is 5. Then in fully connected layer, there is a activation function softmax. Softmax. Last thing is my classification layer. Like this. Here also, first one is the image input layer, convolution 2D, next pooling 2D, convolution 2D, next pooling 2D, fully connected, softmax, then classification. Like that, here I use, here I add all the blocks. Now my work is not done. I added all the blocks, but these blocks are not connected now. So I have to connect now. For the connect, here, if we go here, then is a circle is showing here. By click this circle, you just go down, then it connected. Like this, connected. Connect. Like this, you have to connect first. Now my model is connected. If we show in feed view, then click feed view. If we click auto arrange, then it can be auto arrange. Now all my model are connected. Now I create a simple CNN model which have 2 convolutional neural network, 2 max pooling, and 1 fully connected layer. You can use any type of. You can use 1D layer, 2D layer, 3D layer, then transpose also. Here you can use some encoder decoder model also by using transpose convolutional. Then LSTM also, here also sequential learner like LSTM, BiLSTM, GRU, sequence to sequence. Then activation function different ReLU, Licky ReLU, Clipped ReLU, TANH, like this. Then also batch, here we can also add a dropout or batch normalization for preventing the overfitting condition. Here dropout layer, batch normalization layer, like that. There is different many types of layer is there. So just drag and drop and make the connection. Then your model is done. You no need to code anything and no need to go anywhere. Just go your deep network designer, then drag and drop and connect it. After connect, go to the export, then generate code. Simple. If I click generate code, then all the code is generated for me here. It's so simple. Just copy, go to your folder, then just paste. Done. Your work is done. Like this. Image input layer, your dimension, then name, normalization. Here we use rescale 01, here we use Z score. Then 2D layer, max 2D, con 2D, like this. We use different layer. After assigning the layer, then go to the train network function. Just train your layers and options. Then you classify your X test and you train your model. Like this, you can also use your model with. If I run this and plot, here we use some LSTM layer. Here we use LSTM layer, like image input layer. First we take image input layer, then configuration 2D layer. Here also you use batch normalization, then max pooling. If you use ReLU layer in between, then sorry, LSTM layer, take the LSTM and put it here. Put it here and make the connection. Like this. Now your LSTM in between your max pooling and fully connected layer. If you use GRU layer also, you can add the GRU layer anywhere. By this, you can develop your own network. And after developing your own network, you simple go here and train your network, and you classify your model. So here the class how here I hope you all understand how we classify by using the machine learning technique and deep learning technique. Also use some app functionality like for machine learning, use classification learner this, and for deep learning use deep network designer. By this you can only use the drag and drop technique for creating your network and go here for train the network. Okay, any doubt? Hello?
No, sir. No, sir. No.
Okay, sir. Puneet, sir? Hello? Prasenji, sir? Hello?
Yes, please tell me.
Okay, sir. I have done.
Okay, you have completed. So
Yes, sir.
actually, yeah, dear participant, if anyone having any doubt related to the code or explanation, if any point of the discussion, if you having any query, please ask. Please unmute yourself, ask the question, and let us know your queries.
Sir, can you show me once again actually how to go to that deep network designer?
Okay.
Once again, actually I missed
Okay.
that part due to
Okay.
network issue.
Okay, so in MATLAB there are different tabs: home, plot, apps. Okay. Editor, publish, view. So go to the first apps. There is a call apps tab. Then in apps, go there and click here classification learner. Classification. Here you can see the classification learner. And ensure that by doing this, you have to install the classification package also in your MATLAB by going to this. Here arts on, get arts on. Here you have also, otherwise it not show there. Here you can show first and first you have to
The screen has become black.
okay. Am I audible?
Yeah, you are
Yes, you
audible.
are audible, but your screen is not visible.
Okay, actually there is some technical issues. Okay, I am only told. First you have to go to the apps, then click the classification learner. Then by click this, the classification learner is open. For deep neural network, go to same app, then open the deep network designer. Then deep network designer is open. And for this, you have to install the deep learning toolbox and machine learning toolbox first. Okay. Hello.
Okay. Yes. So these deep learner, deep network designer is available only in 23 version, or it is available in earlier version as well?
No, earlier version as well.
Okay.
Hmm. Okay. Any other doubt?
And dear participant, is there any doubt? So if you have any queries, please let us know. Otherwise, we can.
Sir, I have a question. Sir, if I want to work on offline mode, then how much it take the system requirement as a hardware, and how the cost it is? I think we need to purchase the license for MATLAB. So how much it does cost?
Okay. For system requirement, if you use SSD of 256 GB is enough. NVMe, Samsung NVMe 256 GB. Or for RAM configuration, you have to
Okay,
use.
is there any minimum RAM required?
Yes, 8 GB is minimum nowadays. Otherwise,
Okay,
it will be
sir.
crash.
Okay. And how much cost if I want to purchase the license for MATLAB 2023?
Actually, we use for Institute MATLAB. So actually, I don't know about cost. Please Google
Okay.
it out for costing.
Regarding the cost, although I do not know the exact number, but there are different versions available of the MATLAB. For this, there is a student version is also there. So you can check in the student version, those deep learning designer apps are there or not. But if it is there, then probably it cost around 1,000 rupees and it's close to 1,000 rupees for
Okay,
student
that means
version.
there is the student version is available.
Yes, it is available.
Okay. Thank you, sir.
Sir, I have one more doubt, sir. Hello, sir.
Yes,
sir.
Hello. If you are the VG19, VGG16, VGG19 architecture, the deep learning, it will take more time for training them, around 6 hours or 7 hours.
Yes.
Any or we stop whenever we get the accuracy, we can stop the training. That is a correct technique, or completely must training up to end of epochs. How much epochs we can make?
No, you can use callback function.
Oh, okay.
You can use callback function because if we let you use VG16 and epochs 200, and you see after 100 epoch, the loss is not minimized or accuracy is not enhanced. So you can use the callback function. By this, the model automatically see the loss is not reducing drastically. So it will stop and return the result. So it stop purely function.
Oh.
Yes. Any other?
Any other queries from the participants here? If you are having any doubts, please let us know.
Sir, if any doubt arises, actually later on, actually during right now we have only focused on the demonstration. So we have not using the mat. I mean, personally, I couldn't use the MATLAB, and I couldn't go through step by steps what's happening. So if during that process, if I go through any sort of issues, then I will get it back. I will get back.
Okay, definitely, sir. We will share the contact details of the corresponding professor. So definitely you can communicate, professor.
Oh, sure, sure. Thank you.
So any other queries from other participants? So basically it's a hands-on session. So we are able to demonstrate more than on any kind of technical content. So any
Actually,
other queries?
considering the duration, actually, we only means Pratyush only demonstrated how the things can happen. But of course, you can experiment the things. All the files and the codes are with you now. And at any moment, if you have any doubt, yes, you may contact to me or to the Pratyush. We will share the email ID of the Pratyush also, so no issue with that.
Okay, thank you, sir.
Thank you. Any other queries or any other questions?
Sir, how I can apply the reinforcement learning to my application?
Actually, in MATLAB, there is no option for reinforcement learning because reinforcement learning is separate from the deep learning or machine learning. So it is purely different. So there is no option in MATLAB for reinforcement learning.
No, Pratyush, there is another
Okay, sir.
toolbox.
Thank you.
Okay, so yeah, let me clarify the answer. The point is the toolbox we have demonstrated for the classical machine learning models and the deep learning models do not incorporate the reinforcement learning. However, recently MATLAB have introduced a separate toolbox for the reinforcement learning. So you can do that through the MATLAB only, the reinforcement learning now. But again, you have to download, you have to install the reinforcement learning toolbox separately.
Okay, sir. Thank you, sir.
Sir, I am also having one question. May I ask?
Yes, sure, sir.
Sir, actually, how we can apply the responsible AI in this domain? Because I guess that is very much that could be very much effective learning strategy for this kind of application. So, if you can give a brief idea that. Because responsible AI now a buzzword, so we just need to know something about it, what it is, and how it could be useful.
Yes, sir. So in fact, I will ask to Pratyush to comment more on that. But before I will say that regarding the tool, I was attending one particular presentation from the MathWorks person. He also mentioned that yes, MATLAB also have the facility to execute the responsible AI concepts through the MATLAB. But I have not done till now through the MATLAB. Python, yes, we are doing in this particular domain where Pratyush can more because he is directly that task. So Pratyush, you regarding your observations.
Actually, when you open the classification learner, there is a section is called plot. If we click this plot, in the last tab of there is a called responsible AI plot, and in MATLAB only partially dependency of responsible AI is there. And I see in some lower version like 2020, 2019, there is also some SAP or Lime type of responsible AI there. So yes, in MATLAB also there is a responsible AI now onward.
Okay. Sir, was this question, or you would like to ask how we can means how responsible AI may help women?
No, that is actually I wanted to know that if I want to use MATLAB, then how I can use
Okay, okay,
responsible AI. So I
okay.
think I got my answer. As well as if you say a line like how it is different from any other DNN, then again it could be helpful for us to know a
Yes.
line
So
to
fact is
differentiate.
that it is not different. Is not different with the D. Actually, we talk about the responsible and when I'm saying responsible, actually I'm talking about explainable, where it does not deal with designing of the model. It deals with the explanation of the model. So whatever the model we have created, the explainable AI techniques like the means whatever it is Lime or whatever it is, they try to explain on which particular features or on which particular part of the signal the model is trying to look on.
Yes, sir, I got it. That means what responsibility that AI may be taking, that is what it is called responsible AI. Am I right, sir?
Yeah, yes, in that sense that we want to say that why the model is taking that decision, means we want to make the model responsible regarding the decision.
Oh, okay, okay, got it, sir. Got it, sir. I think it is now completely clear to me, and as well as Pratyusa also told us that how we can get it from MATLAB as well. So I feel that we have got enough knowledge related how it can be applied to real life problems, as well as how it can be directly implemented. And he also explained each step how to implement it, and that is quite more than our expectation. So I personally feel very lucky to have this kind of session for this FDP come short term course. So actually we are grateful to have this session for you, sir. Thank you so much.
Okay, I hope the participants also understood the basic things regarding how to use the different tools, although means that is not our purpose to promote the use of MathWorks, but we demonstrated through the MathWorks MATLAB. The same things can be done through other platforms like Python and various other platforms. So that is not means the crucial thing, but I hope everyone get to know that how these concepts works, how these concept takes place. So I will share these slides with you, Dr. Prasanjit or Arnab. You may share with the participants. I will update that slide with the recent papers, and then I will share.
Okay, sir. Thank
Thank
you
you,
so
sir.
much.
Yeah.
Okay. And thank you, Pratyus, for conducting this nice hands-on session.
Okay.
Okay, sir.
Okay. I think we will
Thank you,
leave
sir.
now. Prasanjit.
Yes, yes, sir. Thank you for that beautiful session. So now, okay, sir, for delivering a very nice presentation to us. Thank you, sir.
Okay. Okay.
Okay, sir. I am now leaving.